Garcia, Mikhail Shkaralevich, and Christian Komo. And the team at Aina Robotics came together to launch an ag tech robotics company after they won the Productivity Award at the Farm Robotics Challenge in spring of 2025. The following summer, they traveled to Silicon Valley to pitch their startup at Plug and Play, where they were established strong connections in the ag industry. Aina Robotics is now seeking its first round of investment to develop a tele-operated robotic platform for produce harvesting and data collection for vision, language, action models. Aina Robotics today will present on developing a tele-operated robotics platform for produce. Gentlemen.
Thanks for that. Does this work?
Yes.
Okay.
Yes.
Okay. Thanks for the intro. This is going to be kind of like a demo of the tech we were developing and a little bit of a pitch at the same time. So we're just going to go into the problems we're solving and tell you about Aina Robotics. Which direction arrow do I press? Or is it on?
Yeah, the arrow should work.
Maybe the mouse.
Oh, we can.
Oh, right here.
Try that.
Yeah, let's do that. Okay.
Okay.
We're going iPad mode.
Yeah.
Okay. So we all know the problems with agriculture. It's very difficult, and a lot of the younger folks don't want to get their hands dirty. So we're experiencing shortages in labor, and our farmers are getting older. And you can't really dig in the ground when you're 100 years old. So we're gonna need to address this issue. So we know that the operation costs are also increasing. With labor shortages, people are gonna wanna charge more because demand shortages. Demand goes up with the labor shortage. So labor costs going up, and there's an increased demand for migrant workers, but we all know there's complications with that in current times. So, our mission is to address this through automation, and robotics seems to be the right path forward right now, and powering robots with AI is also what seems to make sense in the current times.
Well, there are no shortcuts to true autonomy. That's why we're executing our mission through the strategic four-phase approach. Could you go to the next one?
Oh, yes.
So currently we have successfully achieved our first phase, where our vision-based intelligence system consisting of an aerial drone and a ground rover is capable of providing farmers with such insights as how much yield to expect, what is the best harvesting time, and just the general fruits crop mapping of the field. This information is essential in times of workforce shortages, and we have also successfully tested our MVP at the local branch of Dole Plantation in Hawaii. So our technology has proved itself by securing us the Productivity Award in the International Robotics Challenge this year. And next slide. So we're currently seeking funding to move into our next phase. We're seeking around $300,000 to start building our tele-operation system, basically connecting a human remotely to a robot system. And also we're plan building the data infrastructure to collect all this data from the human and from the human input and the rover's sensors to essentially feed our automation system in the future phases. Our phase 3 is mainly focusing on scaling up the infrastructure, cost cutting by mass production, and large-scale data collection in general. Also, this is our proposed operation at the Dole Plantation in Oahu. Currently, Dole is capable of only harvesting around 14% of their available land due to labor shortages, and our proposed operation would double their acreage. We estimate to bring them around $16.8 million as an increase in revenue. And also, one of the issues that Kai mentioned is that labor cost increases. So our proposed operation would bring the labor cost down by 40% through the use of tele-operation stations. So this is just to summarize our impact with a partnership with the Dole plantation. We estimate to bring them around 18.6 million of estimated added value. Plus, we plan to gain around 224,000 labor hour training, which is essential for the training of the artificial intelligence system.
So what are we using that data for? So after teleoperations and large-scale data collection, we plan to use our action data into training a VLA model. A VLA model, which is stands for Vision Language Action Model. You can think of it like this: ChatGPT and popular large language models act in the language and the vision domain, where they can understand text and input. They can understand the context of images. Once we introduce a VLA model, it takes it a step further by taking that understanding of images and language, and it turns it into action in the real world, such as what we're aiming to accomplish is autonomous tasks such as autonomous harvesting, autonomous liming, autonomous fertilization, a wide range of farming tasks.
So the market is it's hard to measure because every part of the world is doing farming, but we know that it's growing in demand, and I'm not sure how accurate these metrics are, but we know that there is demand for automation, and we can't afford to go into a food crisis. Let me talk more about the different markets. So we're going to start off here in the islands and establish ourselves with some partners here. Get to know some more of the farmers out here. So if you are interested, please talk to us. And then we do have connections over in the west coast of the United States, so we can penetrate the market there. And we also know some folks in South America, and we also know there's demand in Southeast Asia growing. So here are some of the established competitors. The term VLA is kind of new, and there are no real big players using that yet. And also there are not a whole lot of tele-operated systems being used in farming. So with the combination of those two systems, we didn't really know where to fit ourselves into this matrix, but with the teleoperation, we do cut costs, and with the VLA, we do enter more of a general applications. This is our team as of now. Most of us, or Mikhail and I, are computer science majors, and Christian's doing his computer engineering. And we'd like to thank our advisors, and especially Jason, for bringing us out here. It's a pleasure to meet everyone here, and we look forward to getting connected. Okay, so this is kind of like the perfect spot. We're getting, year-round, somewhat consistent temperatures here, so that also allows us to test year-round. We don't have to pause for any freezes or for any insane heat waves. So I think we're in a pretty unique situation where we can develop some awesome tech. Thank you.
Excellent. Yeah, so just a real quick question here. You had one graphic where you had a person in a room controlling the drones and stuff. What's the purpose of the person? And why can't you do everything automated?
So it's essentially for data collection. All the data from human input will be mapped to the data from the sensors, which then will be acting as a fuel for training of the AI model. So basically, that's how AI is going to learn what to do in the situation, how to, let's say, approach a fruit based on the LiDAR sensors and the human arm control.
So, a
So,
product
so
like ChatGPT-
eventually, you won't need to. Is that right?
No.
We strive for creating a VLA system which will enable us to perform farming tasks with minimum human input.
Yeah, so you're wondering like, why can't we just go straight into automation? It's kind of like ChatGPT had to be trained on the entire internet basically. Instead of using the internet, we're kind of creating our own data set with the tele-operation.
Okay, very good.
What sort of latency do you think you can cope with the teleoperation? Like, where physically could the operator be in terms of the number of milliseconds between?
That is still something we're testing. That's actually one of my main concerns, because if we want to hire people, overseas to do a teleoperation, then the latency becomes a big issue. So yeah, we're exploring different options for that. I think that's something we need to talk about.
If you read the history of US drone operations,
Yeah.
it'll teach you a lot.
If you were just doing it in Hawaii, though, would that be an issue, or
Very much that's
still an issue?
It's almost negligible. It's
Oh,
yeah. I mean, you're going to be far next to the robot at that point.
So another reason why Hawaii is a good place
Yeah.
to
It's the
develop
best
that
testing
latency.
grounds.
Yeah. Right on. That's good. Okay, great. Thank you.